Hey folks, today's topic is counting principles of probability. There's our probability is what we're going to use. I mean, those are the odds of something happening. Now, when you're talking about something like rolling some die, a die, let's make it real easy. It's pretty easy to calculate the probability. What's the probability of getting a 1? Well, 1 out of 6, because there's one on a die and there's 6 different things that could happen. But it gets more complicated when you talk about situations where it's not so easy to count up how many different things could happen. How many different ways could the first 3 places finish if 9 people compete in a race? Well, you could win and then I could get second and Wojo could get third, or you could win, Wojo could get second, I could get third, or I could win. And then you see that's tough to count. There's a lot of different ways to count. And that's what permutation and combinations are. There are ways to count up situations that are not so straightforward to just look and count and go from there. So what's the difference between the two? So we're going to start off with a permutation. A permutation is a situation where order does matter. Now, I usually do this with dashes that represent my choices. I'm going to show you with the examples what I mean by that, but each choice you have, I do a dash to represent that choice, and then I talk about how many options there are for that choice. Your calculator will do this has a feature for you called permutation on your calc, NPR, and that's under math, and then PRB, the same place that we found factorial a couple units ago, and then NPR. I don't use NPR, I use dashes, but it's up to you. Combinations, order does not matter, and then when I do that, I can't do that with dashes, and we have to use NCR. Let me get into some examples, and hopefully the difference between a permutation and a combination would make more sense. Example 1, how many ways could the first 3 places finish if 9 people compete in a race? Okay, so first, second, and third, does order matter there? If you get first, is that different than you getting second? Yes, yeah, order matters. Now I could change this question and make it so that order does not matter. I could say, how many ways could anybody finish? How many ways could the top 3 spots finish? How would I want to say that? Let's go to the Olympics. This question is saying, how many ways could the first 3 places finish? In other words, how many ways could you have a silver or gold, silver, and bronze at the Olympics? Well, that's different if Usain Bolt gets first versus if Usain Bolt gets second. I could change that and say, how many ways could the medal winners finish if 9 people ran at the Olympics? See how that's different. Now, if Bolt gets first place, or if he gets second place, or if he gets third place, that's all counted the same way. So if I got first, Usain Bolt got second, obviously, and Wojo got third, that would be counted the same way as if Wojo got first, Bolt got second, and I got third. Those would count up the same way. So you have to first decide, does order matter or does order not matter? So how many ways could the first 3 places finish it? That means order does matter. So there's how many different ways could that happen? Well, let's start off by counting how many choices we have, or how many options we have, how many decisions. If you got to magically decide who gets to get first in the Olympics, who gets second, and who gets third, how many choices would you have to make? You'd have to make 3 decisions. You'd have to say who's in first, and you'd have to decide who's in second, and you'd have to decide who's in third. And now I'm saying and like that because and or mean 2 different things in a story. When it comes to probability, and usually means multiplication. Or usually means addition. Okay, so now let's go back to our decision making here. What did we say? You had to choose who got first place, and you had to choose who got second. So there's going to be a multiply between these two. And you had to decide who got third, so there's going to be another multiply. All right, so let's go to that first choice. Your first choice is how many, so let me try that again. How many options do you have for the first choice. Well, if there's 9 people running the race and you just get to decide who gets first, how many options do you have for first place? Well, anybody could be first. You could choose anybody from the 9 people running. Then I move on to my second choice. Now remember, you've already picked somebody to be in first place. So how many options do you have for your second choice? Well, you've already picked somebody to be first. That means there are now 8 people left over that could be in second. Now you've picked a person for first, a person for second. How many how many options do you have for third place? And then there's 7 options. I'm going to stop there because they asked just the first 3 places. If they said, how many ways could a 9-person race finish? I would just keep going downhill until I made all 9 choices. But we only have to do the first couple. 9 times 8 times 7 ends up being 504. Now, if you're somebody, I always struggle with the NPR. So I don't use NPR. I think this makes a lot of sense. That's the way that I get it. If you understand how this works, feel free to use it. So the way you would use NPR is you'd say, how many people am I picking from? This is a group of 9. I'm picking 3 people to get in first place, and order doesn't matter. So I'm going to use 9 permutate 3. So you have to put the 9 in there first. Put the 9 in there first, then go to math, and then over here is PRB. And then, go down to NPR. And so the number in front of the 9 in front of the N goes in the N spot. Whatever you put after R goes in the R spot. So that would be 3. And you see, you get the same result. So if you can do it with NPR, go for it. Go for it. I prefer dashes, and I'm going to show you how to do everything with dashes. All right, next up. How many phone numbers are possible if the area code must start with a 3, a 4, or a 6, and the prefix may not start with an even number? Okay, so what are we talking about? How many? You can magically pick your phone number. How many choices would you have to make? Well, let's first decide. I shouldn't say that yet. Does order matter in a phone number? Is the phone number 865-3101 the same as the phone number 865-3110? So I just transpose the last 2 digits. Yeah, that's a different phone number. So order matters in a phone number. So if you could magically pick your own phone number, how many choices would you have to make? Well, you'd have to pick the area code. So the first 3 things are what we call the area code. First 3 things, I should say the first 3 digits. This is what we call the area code. Then you would have to choose 7 more digits. The next 3 numbers. This is what we call the prefix. And then we have 4 more digits. This is what we call the suffix. Wish I'd have to leave myself a note. I like the way I wrote that better. So anyway. All right, so now we come back, you're going to choose your first number and your second number and your third number and your fourth and you get to pick all these numbers. So I'm going to go ahead and put multiplies in between them. So your first digit of your area code, there's a restriction. It says it must start with a 3, a 4, or a 6. So how many options do you have for the first number of your area code? You only have 3 because it has to be a 3, a 4, or a 6. You have to pick one of those 3 numbers. What about the rest of the area code? Is there any restriction on that? Nope. So how many digits are available for your next number? Well, you could pick 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't pick the number 10 as a digit, but don't forget you could also pick 0. So there are 10 digits that you could pick for a number. How about for the next one? I could have 10 for that one as well. Now, the prefix, that's where we are here. They talked about that it may not start with an even number. So you have to eliminate the evens. So that would leave behind 1, 3, 1, 3, 5, 7, and 9. So there are 5 available numbers for my options for the first number of the prefix. And then there are no other restrictions, so you could use any of the 10 digits to calculate the rest. Then we would type this into our calc, or just remember 5 times 3 is 15. 1, 2, 3, 4, 5, 6, 7, and it would have 8 zeros. So that turns out to be 1,500,000,000. So according to these restrictions, you would have 1.5 billion different phone numbers available. Okay, so from a group of 12 boys and 14 girls, how many different ways could you choose 2 boys and 3 girls? So let's first decide, is this going to be a dash where we have order matters, or is this going to be a NCR where order does not matter? So it just says you're choosing 2 boys and then you're choosing 3 girls. If you're the first boy picked or if you're the second boy picked, does it matter? I mean, think about it. Let's say I'm taken from our class. Say that there's 26 kids in our class, 12 boys, 14 girls. I'm going to take 5 people to lunch. I'm going to take 2 boys and I'm going to choose 3 girls. If you're the first boy picked or if you're the second boy picked, does it matter? Are you still going to lunch? No, it doesn't matter. If you're the first girl, the second girl, or the third girl picked to go to lunch, it doesn't matter. So order doesn't matter here. If you're picked first or if you're picked last, you still get to go to lunch. So instead of using dashes, I'm going to go right to NCR. So what would that look like? That would look something like so we're going to start with the boys. We have a group of, the N stands for how many there are. The R stands for how many you're choosing. So from the boys, there are 12 boys to choose from, and we are going to choose 2 of them. And means multiply. From 14 girls, I'm going to choose 3 of them. This is something that I can compute. I wouldn't try to compute it in my head. I would go to my calculator. So I got to put the 12 in first. Math, NCR, 2, times, then I've got to put the 14 in first. Math, PBR, NCR, 3, and you get 24,024. So out of a group of 12 boys and 14 girls, there are 24,000, over 24,000 different ways that I could pick 2 boys and pick 3 girls. Crazy. These numbers get real big real fast. Okay, how many 5-card hands are available? How many 5-card hands can be formed with exactly 3 hearts? So let's get out our Unit 5 reference sheet. And let's talk about how a deck of cards work. So if you don't know how cards work, this is a little chart to kind of keep things organized. There are 52 total cards in a deck of cards. Half of them are red and half of them are black. So there are 26 red cards and there are 26 black cards. The cards are separated into 4 categories called suits. There are clubs, diamonds, hearts, and spades. Spades and clubs are black. Diamonds and hearts are red. Then each suit has the same number of cards. They all have an ace, which is kind of like a 1. And then it goes 2, 3, 4, 5, 6, 7, 8, 9, 10. And then they have what's called a jack, a queen, and a king. A jack, a queen, and a king are called face cards. There are 12 face cards because there's 3 per suit and there are 4 suits. So 3 times 4 is 12. If you take 52, take away 12, that leaves you with 40 non-face cards. So we have face cards and we have non-face cards. So you take the 52 cards, you divide them into 4 suits. That means that there are 13 cards in each suit. There are 13 clubs, 13 diamonds, 13 hearts, 13 spades. Or we can look at it from the other perspective. If you have 13 clubs, then you have 39 non-clubs. 13 diamonds, 39 non-diamonds, 13 hearts, and so on. And then you can also look at it from the perspective of each individual card. How many aces are there? There are 4 aces. which means then 52 take away 4 leaves me with 48 non-aces. There are 4 2s, so there are 48 non-2s, 4 3s, and so on and so on. So there are 4 jacks, there are 48 non-jacks. Anyway, that's how a deck of cards works. Most accounting principle or probability, we're going to do some probability in a minute. Right now we're just counting. The most card problems deal with 5-card poker. So this is going to be a 5-card hand from poker. How many 5-card hands can be formed with exactly 3 hearts? So from the deck of cards, we're going to select 3 hearts, but we have to pick a total of 5 cards. So even though it doesn't say it, there's something implied here. You're going to pick 3 hearts, and you're going to pick what else? 2 non-hearts. Now, if you're going to pick hearts, you can't pick hearts from all 52 cards because they're not all hearts. You have to narrow down. If you're going to pick hearts, they have to get picked from the set of all hearts. So how many hearts are there? Well, there are 13 hearts. And how many do we need to choose? We're going to choose 3 of them. Now, some people would say, there's my answer. No, how many cards have you picked so far? Right now, from the 13 hearts, you've chosen 3 cards. You only have 3 cards. In poker, you need 5 cards. So I need to pick these 3 cards, and remember, and means multiply. And from the deck of non-hearts, I have to pick my other 2. Because those other 2, if they're from the deck of hearts, then I would have more hearts than just 3. So from the 39 non-hearts, I'm going to choose 2 more cards. A couple of things to point out here. 13 plus 39 adds up to 52. That's the whole deck of cards. And 3 plus 2 adds up to 5. That represents your hand. All right, grab your calc, type this in, see what you get. Hopefully you got 211,926. All right, so let's take this idea now, extend it into the world of, we have exactly versus at most versus at least. How many 5-card hands can be formed with at most 3 face cards? So if you have at most 3 face cards, that means you could have 3 face cards, or you could have 2 face cards, or you could have 1 face card, or you could have no face cards. And we have to account for each one of those situations. So let's take a look. We said that at most 3 face cards means you could have 3 face cards. So I'm going to pick 3 face cards. Now, I have to pick them from the group of face cards. So there are 12 face cards. I'm going to choose 3 of them. The problem is I only have 3 cards in my hand, so I have to finish the rest of my hand. I picked these 3 cards, and I have to pick 2 more cards from the group of non-face cards. And there are 40 non-face cards. So what we've done so far is we've accounted for the number of ways that you could pick 3 face cards. But remember, it said at most, so you could pick 3 face cards, or, you hear that keyword, or, go back to the top, or mostly means addition. So I'm going to take the number of 3 face cards, or I could pick 2 face cards, which means from the group of 12, I would choose only 2. But I have to finish the rest of my hand. So there are 40 cards that are non-face cards, and I need 3 more cards. This is the situation where there are 2 face cards. Or I could choose 1 face card, which then means I need to choose 4 non-face cards. This is the situation that represents 1 face card. And remember, this said at most 3, which means at most 3, you could have none and still fall into the category of at most. So, or I could also pick 0 face cards. 12 choose 0, and then I would pick all 5 of my cards from the group of non-face cards. This section would represent 0 face cards. So we have accounted for all the different ways that you could have at most 3 face cards. Now, you could just wait and see me write down the answer, but I really hope you take the time, practice typing all this in, because there's a lot of mix-ups that could happen between the multiplies and the add. So pause it, grab your calc, and try to calculate this. All right, let's see how you did. You should have gotten 2,578,368. How many 5-card hands can be formed with at least 2 queens? So now we're going to think of this from a different perspective. We need at least 2. So I could have 2 queens, or I could have 3 queens, or I could have 4 queens, or I could have 5. Wait. Why wouldn't that work? Why can't I have 5 queens? Unless you're an old West card shark, that's not legal because there are only 4 queens in a deck of cards. So we're going to look at all those scenarios. So I always start with the one that they give us in the problem. That's how many ways could we have 2 queens? So from the deck of queens, there are 4 queens. I'm going to choose 2 of them, and I need to finish the rest of my hand. So if there's 4 queens, there are 48 non-queens. I've picked 2 cards. I need 3 more. Or, so let me just highlight this. I kind of like what I did in the last one. This represents can never pick colors. So bad at that. This represents what? 2 queens. Or I could choose 3 queens and finish the rest of my hand. That represents the scenario where I've chosen 1 queen. My bad. That's the scenario where I've chosen 3 queens. Or I could choose 4 queens and then pick 1 card from the group of non-queens. And I would stop here because I can't pick more than 4 queens in a fair deck of cards. So I would encourage you to pause here and try to grab your calc, see if you can figure this out. You should get 108,336. Okay, so the front, most of what we talked about was ways to count. Now we're going to take those ways to count and we're going to turn them into ways to calculate probability. Because probability is very simple to calculate on the surface. Probability is the number of ways an event could happen divided by the total number of things that could happen altogether. So for instance, when I flip a coin and I try to get tails, my event would be trying to get tails. So that means how many ways could you get tails when you flip a coin? You could only do it one way. How many different things could happen when you flip a coin? There are 2 different things. So that's why it's 1 out of 2. So what's the probability of getting a red card or a 9? So this gets a little bit sneaky here. So you can go to your deck if you need to count and look things up. Let's count the probability. How many ways could we get a red card? Let's start with that one. Well, there are 26 red cards. That's the number of ways my event could happen out of the total number of things that could happen. There are 52 things that could happen. Or, what does or mean again? Add. A 9. How many ways could we get a 9? There are 4 9s out of 52 things that could happen. Now, it kind of feels like that's the answer, but that's a little sneaky. You got to be a little careful. Because think about it. Let's say I had everybody who I had class, first hour, I had everybody stand up. And I said, everybody who is a girl or everybody who is a senior, go out in the hall. So will there be any, let's say that you are a girl who is also a senior. Would there be 2 of you out in the hall? No, right? I would say everybody who's a girl, go out there. So all the girls go out. And then I would say everybody who's a senior, go out there. But there's not, if you're a girl who is a senior, there's not going to be 2 of you out there. You're just out there because you fell into both groups. So you've got to be careful when you're trying to count up the way something could happen. You've got to be careful that you don't count the same thing twice. In other words, is there any situations where there is a red card that is also a 9? Yes, there are 2 red 9s. So I need to subtract 2 cards out of the 52. This came from the subtract 2 red 9 cards. So in here, let's talk about the 2 cards. It's the 9 of diamonds and the 9 of hearts. Did the 9 of diamonds get counted in the red cards? Yes. Does the 9 of diamonds get counted in the 4 9 cards? Yeah, so it got counted twice. So you always have to subtract off anything that repeats. So let's go ahead and now calculate this. 26 plus 4 is 30. Take away 2 is 28. 28 out of 52 should always, we can clean up if we can. 4 goes into both of those. 4 goes into their 7. 4 goes into their 13. 7 and 13 are relatively prime. So 7/13. The chances of getting a red card or a 9, if you pulled from a deck of cards 13 times, it should happen 7 out of the 13 times from a probability point of view. Makes sense, right? A little bit more than half. 7 out of, no. Yeah, 7 out of 13. Is that more than half or less than half? Yeah, a little bit more than half. That makes sense because all the red cards, you get a 50% chance that you'd get a red card. You're going to increase your chances if you add the 2 black 9s into the pile of red cards. Okay, so what's the probability of getting a diamond or a face card? So I'm going to encourage you to pause here. Try to do this on your own. Okay, so here it is again. Or means add. So how many diamonds are there? There are 13 diamonds out of 52 total cards. Or I could pick a face card. There are 12 face cards out of 52. But don't forget, you've got to subtract off anything that repeats or anything that gets counted in both groups. So is there anything that is a diamond? Let me go up here. Subtract 2. Subtract cards that are red and 9. There, I think I like that better. The cards that are red and 9 they get counted twice, so you got to subtract that off. So a diamond, that's a face card. There are 3 diamond face cards. The Jack of Diamonds, the Queen of Diamonds, the King of Diamonds. They all have a common denominator, so I can combine 13 plus 12 is 25. Take away 3 is 22. Out of 52, those are both divisible by 2, and I get 11 over 26. Those 2 are relatively prime. So 11 out of 26 chances of getting a diamond or a face card. What is the probability of getting a sum on a pair of 9 dice? So let's pause here, go back to our Unit 5 reference sheet. These are all the possible things that could happen when you roll 2 dice. You could get a 1 and a 1, a 2 and a 1. Now look, this is a different scenario. So I have 2 different colors. I have a white die and I have a black die. When I roll them, if you get a 1 on the white and a 2 on the black, that's going to be different than a 2 on the white and a 1 on the black. That's why we count those as different scenarios. So there are 36 different things that could happen. Now notice we don't do that with a 1 and a 1 because there's a 1 on the white and a 1 on the black. There's no way to like flip-flop that around. If they flip-flop them around, it's still the same combination. Same thing with the 2 and the 2, the 3 and the 3, the 4 and the 4, the 5 and the 5, and the 6 and the 6. But everything else has a kind of like a symmetrical situation. So I have a 2 and a 1 or a 1 and a 2. I have a 3 and a 1 or I have a 1 and a 3, and so on. So there are 36 total things that can happen. When I roll 2 dice, there are 36 outcomes. That's it. No more, no less. So that's because 1, 2, 3, 4, 5, 6 multiplied by 1, 2, 3, 4, 5, 6. Another way to think about it is there are 6 things that could happen on the white die. Then there are 6 things that could happen on the black die. So you roll them both at the same time, white and black. So that would be 6 times 6 is 36. So what is the probability of getting a sum of 9 on a pair of dice? So let's look which one of these, when you add the dice together, would give you a sum of 9. So 6 and 1, no. 6 and 2, no. 6 and 3, yes. So 6 and 3, 5 and 4, 4 and 5, 3 and 6. Those are the only ways. I'll give you a little hint. It always kind of goes on this diagonal. Those are the only ways that you could get a sum of 9. So there are 4 ways to get what we want. How many ways could our event happen? How many ways could we get a sum of 9 when you roll 2 dice? How many things could happen altogether when you roll 2 dice? We said that there's only 36 things that could happen. That reduces. So if you roll 2 dice 9 times, probability says you should get 1 sum of 9. Now you could get more, you could get less when you actually test it, but from a probability point of view, it should happen 1 out of 9 times. What is the probability of rolling a 6 on a die 3 times in a row? So this changes things a little bit. So this time I'm using just a die. So I'm taking 1 die, I'm rolling it, I'm seeing what I get, I'm picking it up, and I'm rolling it again. I'm picking it up, and I'm rolling again. Do you hear what keyword I'm saying? And. So I'm picking it up and rolling again. So let's look at the probability of the first roll. How many ways could you get a 6 when you roll a die? Well, there is 1 6. That's the event. Divided by how many ways could anything happen? There are 6 different things that could happen when you roll a die. And I'm going to roll again. So and means multiply. How many ways could I get a 6 on the second one? 1. How many things could happen? 6. And I'm rolling again. How many ways could I get a 6? 1. How many things could happen? 6. 1 times 1 times 1 is 1. 6 times 6 times 6, ooh, the secret devil's number 216. So if you roll a die 3 times in a row, 216 times, you should get a 6 every time, only once, from a probability point of view. That doesn't mean if you go home right now and grab a die and roll it 3 times in a row that you won't get 6 the first time, but the chances of that happening are very low. Roll it 3 times and get a 6 each time. The chances of that happening are very low. All right, so that's it for Unit 5. Don't forget that you got your cheat sheet that you can kind of keep organized, or reference sheet, I call it. We can go from there. All right, good luck.